Last time we started quadratic equations, we looked at several different ways of solving quadratic equations. The first one we looked at was actually factoring. Works great when it works. It's basically the rule of thumb with that one. We looked at square roots. Some of them are naturally set up to be solved like that very nicely. Some of them we can force them to be set up that way using completing the square. And so we looked at completing the square as well. And then we left off right here, which is the quadratic formula. So the quadratic formula, you have undoubtedly seen it before. But just as a reminder, when we have a quadratic equation that is set up as ax squared plus bx plus c equals 0, like the standard form, then the quadratic formula comes about from there. So we actually have x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So again, this is one of those things that as you're kind of making maybe a list of the things that you need to have memorized by the time we get to the test, which is several weeks away, but this would be one of those things. There is a lovely song that can help you to remind you what it is if you haven't heard it before. It's the only time you're ever going to hear me sing in class. But it's the tune of Pop Goes the Weasel, if you're familiar with that tune, but it goes something like this. X equals negative b plus or minus radical b squared minus 4ac all over 2a. Some of you are nodding, yeah, you've heard it before. So mnemonic devices can be helpful. If that's one to help you, then you might just write down inside of that phrase, Pop Goes the Weasel. That's what it works with. So the nice thing about the quadratic formula is that it's a set descriptive like equation that you can just plug numbers into to work it every time. So people tend to like this a little bit better than completing the square because completing the square has all these sort of, adjustments you make, right? You make an adjustment if there's a number in front of the x squared. You have to make an adjustment if things end up being fractions. And so sometimes it ends up being a little bit more messy, and this one ends up being a little more direct. So the condition that you have to make sure that you're meeting, however, is in fact that you have everything on the same side set equal to 0 before you start. Otherwise, you're going to end up with some signs that are incorrect, which is going to cause incorrect answers. So our first thing we have to do when we're given the problem below is to move everything to the same side. So I need my 6x to move, and I need my 13 to move. Now, whether you actually show that you're shifting them like that or whether you're able to just see the shift and then write this equation down, it doesn't matter to me. But you do need to have them all on the same side before you start. Okay? So at the very least, you need to be writing this down before you get started. And then we're going to evaluate it by substituting into this equation. Okay? So x will equal negative b. Well, b itself is already negative. It's negative 6. So you can either just write in positive 6, or if you want to keep track of all the pieces, you can write in the opposite of negative 6 like that. I'll write that this time. But understand that I'm perfectly fine if you just put 6 there because you happen to see that. It's plus or minus the square root of b squared, so that's negative 6 squared, minus 4 times a. A is right here in front of the x squared. It's a 1. Times c, which is the third value. That's my 13. All over 2 times a, which is, again, the number 1. So you should show me a step here where you actually put all the pieces in individually, with the exception of maybe you decided to write this as a positive 6 instead of a negative 6. That's fine if you wanted to do that. But you're going to show me a step where you've actually put all the pieces in. And then as you simplify along the way, you may or may not need to show as much detail as I'm about to show, but feel free to show whatever detail you need to. There should be something going on before you just get to the answer here in a minute. You should not go from here to the answer. There's definitely work to be done in between. So as we go through this work, I definitely have a 6 there in front. Negative 6 squared is 36. And then my negative 4 times 1 times 13. What is 4 times 13? It's negative 52, okay? And I'm dividing this by the number 2. Okay, so I kind of just like to do the two pieces that are underneath the radical separately before I combine them. You could combine them all in the same step if you're working with your calculator to do so. That would be okay. But if you do combine them, and you would at this point, what is 36 minus 52? It's negative 16. So you might, in fact, jump from here to here reasonably, and that would be okay. But I'm going to show mine out because that's how I actually think about it. So if I see my negative 16 underneath my radical, then we're back in what we did in chapter P. What is the square root of negative 16? 4i, yeah. So we have 6 plus or minus 4i. Looks kind of like a u. Let's try that again. I over 2. Now we're almost finished, but just like again in chapter P, this can be simplified because the 6, the 4, and the 2 are all divisible by 2. So we will reduce each of them. 6 divided by 2 would give me 3. And then my 4i divided by 2 would give me 2i. And it's a plus or minus between. So we end up with this solution. Now, when we ended up with solutions, or not necessarily solutions, but values at the time in section P7 that had i's in them, there was a special name for that type of a solution. Do you remember what it's called? What kind of a number is that? It's imaginary. The component with the I is imaginary. There's a broader name for the whole thing, though, too.
Irrational.
Not irrational, but you're getting closer. It's called complex. This is a complex number, okay? So as we're seeing this, there's actually 3 different things that could happen, and they all have to do with what happens underneath the radical. So they're happening underneath here. So that value that's underneath is actually called the discriminant. So it's just the value that's underneath the radical, the discriminant. And there are 3 different things that could happen underneath the radical. You could end up with a value that's bigger than 0, a value that's equal to 0, or a value that's less than 0. So our value that we just got was in this last category, the less than 0 part, right? So when we're working with these different types of solutions, they're all going to give us what we would call complex numbers. But specifically, some of them will end up with an I involved, and they're actually going to make it imaginary components like you guys identified. And some of them don't end up with an I involved, in which case we have only the real components. So you see these words over here, real and imaginary, showing up because that discriminant actually tells us which types of solutions we end up having. So when we're working with the first case and our discriminant ends up being positive, okay, that's actually a lot of the time that has happened. All the solutions that we had before on these other problems, if we had done them with the quadratic, not this one, well, not part B, but a lot of these actually had real number solutions, right? So when that happens, we would have ended up with a discriminant actually that was positive if we used the quadratic formula to do so. And that would give us 2 real solutions. So anytime we have a positive discriminant, we have 2 real solutions. When our discriminant equals 0, what's the square root of 0? It's 0. And what ends up happening in this equation then is that we end up with a plus or minus 0 right here. Oh, that color did not show up. Let's try that again. A plus or minus 0 right here. And when I have plus or minus 0, there's really no plus or minus to do, right? All of this cancels out, which means I'm left with just the negative b on top and the 2a on bottom. I only have 1 solution because the plus or minus gets eliminated. So I have 1 real solution. And then in the last case, when I have the negative, like I just did on the last problem, I don't have any real solutions, but I end up with 2 of them that have I in them, a plus or minus, right, with something with an I, so I have 2 imaginary solutions. Now, if you wanted to confirm this from a calculator perspective or look at a graph of such a thing, the pictures actually look like, so if you take the same equations that we were dealing with before, but you set it as y equals the ax squared plus bx plus c, and you were to graph it like in your calculator, or maybe you know techniques for graphing, which we'll talk about in another chapter. But these actually have very distinct images that show up as well. If it has 2 real solutions, what it means is it crosses the x-axis twice. There are 2 solutions that show up on the x-axis. If you're looking at something that ends up equaling 0 as the discriminant, what ends up happening is that it bounces off of the axis. So you have a graph that looks something like this, where you're not cutting through, it's just bouncing off. So you have 1 real solution, 1 x value. And in the last case, what ends up happening is that you have a graph that just doesn't cross it at all. That's why there's no real solutions. It never crosses the x-axis. So those are the different things visually that happen with these types of graphs as well. So we're going to look at an example of one where it's asking us a much reduced type of question than the last one did. It simply wants us to know how many and what type of solutions there are. It doesn't ask us to find the solution, just how many and what type. So this phrase right here, the how many and what type, I meant to highlight, let's try again, is asking us simply to find the discriminant. That's all. So I only have to find the part that's underneath the radical, namely the b squared minus 4ac. So if the problem had not already been set up so nicely, we would have to get everything on the same side, but this one already has all those pieces on the same side. So we're going to simply be finding b squared minus 4ac. So the b value is -7, so I have -7 squared. Minus 4 times a, the a value here is now a 3. And the c value is also a 3. So what is -7 squared? 49. And then 4 times 3 is 12. And 12 then times 3 would be 36. 49 minus 36 gives me 13. And in particular, I care about the sign. That sign is a positive. This number is greater than 0. So, according to what we've written down before, how many solutions do I have and of what type? 2 real solutions. And if you did want to verify, looking at your calculator, like a graphing calculator, you could actually graph y equals 3x squared minus 7x plus 3, and you would see it cross the x-axis twice to verify that 2-solution conclusion that you came to. Any questions on that? All right.